we need to take a look at different ways of measuring time, because that is going to be quite important when we have some later philosophical discussions on time. And we'll start by looking at two standard different ways of measuring time in relativity theory, which is called coordinate time and proper time. So the coordinate time is the time as measured by one specific frame of reference. But that will be different for everyone, because people have different frames of references, and when they measure the time between one event and another, then they will measure that a different amount of time has passed. But proper time, that's a way of measuring time which is independent of frame of reference, and then it will be the same for everyone. Everyone can agree on the proper time. They will disagree on the coordinate time, but they can agree on proper time. So it's a good way of having an objective measurement of time that everyone can agree upon. So how does one go about calculating the proper time? It's a formula for calculating proper time, which is that you take the coordinate time, the time as measured by the selected frame of reference, squared, minus the distance between the two events, squared. That gives you the proper time squared. So let's say that Steve wants to calculate what was the proper time that Rocky spent on this journey that we saw in the previous example. Well, then he can take the coordinate time, the time that he measured in his frame of reference, that was 5 years, and he can take it minus, he can take 5 years squared minus the distance that he measured. He measured that Rocky traveled 4 light years, and take that distance squared. And then that will give him a proper time of 3 years squared, because 5 squared minus 4 squared is 3 squared. So 5 times 5, 25, minus 4 times 4, 16, is 3 times 3, 9. And if Rocky uses the same method to calculate the proper time for Rocky, then he will say, well, I measured in my coordinate system that 3 years of time passed, and I measured that I didn't travel any distance because I was just sitting still in my spaceship. That is his frame of reference. So 3 years squared minus 0 light years squared equals 3 years squared. So they both agree then with this method that the proper time for Rocky on this between these two events is 3 years. And if we want to calculate the proper time for Steve, we would say that, well, he measured 5 years and that he was just sitting still in his lab. So 5 squared minus 0 squared will give 5 squared. So the proper time for Steve is 5. The proper time for Rocky is 3, and they can both agree on this. And everyone can agree on this, that the proper time is 3 and 5 years for those two. So we see that there is this Pythagorean relationship then on how you measure the proper time, because we see that this 5 years distance, or the time that Steve measured, minus the distance 4 years squared, equals 3 years squared. And it would be the same for Rocky, but then it would be a triangle, because one line would be 0, so it would be a triangle where the sides melt together, so it wouldn't look like a triangle anymore. But it would be the same relationship there. Hypotenuse minus the one line equals the other line when you square all the sums. The relevance of this is that, well, it's good for physicists to have this objective measurement that they can use, where they don't have to care about what reference frame they are talking about, and the proper time is related and connected to empirical events and physical processes, such as aging, for example. Steve's body will age biologically 5 years, and Rocky's body will age biologically 3 years, because it's proper time that determines this aging and the speed of these processes that makes our body become older. But it's important to note for later that measuring proper time is one out of several ways of measuring time. So, for instance, if Steve and Rocky both had went to a gas station and bought a wristwatch that they were looking at in this period, both of them would have measured that it took 5 years, because when you measure proper time, it's in a reference frame that just has this even motion all the time, whereas if you have a clock on your wristwatch on your arm, you will move it in different directions, etc. It won't be this one frame of reference. using light to measure speed, or if they had been looking at Earth rotating, they would have seen both that the Earth was rotating 5 times, and it had been Christmas 5 times, and 5 years had passed, if we by year mean one round around, or one rotation of the Earth. So for Rocky, it would look as if the Earth was spinning faster. But the reason this is important is that later on we'll look at some arguments where people are mixing together different ways of measuring times, and then they get into trouble. So we need to have this clear mind on what exactly are we talking about now when you are saying that 3 years or 5 years, or when time was this or that. What kind of measurement of time are we talking about? That's important, otherwise we are going to get into trouble. But that we'll talk more about in later videos.